In Einstein's most famous equation, E equals mc squared, he showed that energy and mass are intertwined. So a black hole losing energy must also be losing mass, albeit very slowly.
The radiation will carry away energy from the black hole. The black hole will lose mass and eventually disappear. This creates a paradox, because the information about what fell into the black hole appears to be lost, but the laws of physics say that information can never be lost.
Information's tricky. It's not things like names and stories that can't be lost. Maggie met up with cosmologist Andrew Pontzen to find out what kind of information does cause the paradox.
Information is a critical thing in physics. It's telling us where we are and how we're sitting and what we're made out of. We think of all of that stuff as being information.
So this is the parameters that govern the atoms in the universe?
Yeah, exactly. The idea is that if you know everything about how the universe is today, then you should be able to predict what will happen in the future, or work through the equations backwards and predict what happened in the past. But if you want to be able to do that, then you need this idea of preserving information. Now, the problem is, if you imagine something falling into a black hole, you or me, or maybe just put the whole Earth into a black hole. In fact, I can do that for you right now. Yes. So I take my...
oh, phew, just a piece of paper.
Yeah, no, not the real Earth, just a piece of paper. So I pop it into my black hole over here, for which I'm using a shredder. Now, in principle, if you looked carefully enough inside the black hole, you can imagine you've got some bits and pieces in there.
So we could recreate this and put it back together with a long time and a lot of sellotape.
It would be pretty boring, but you could do it in principle. So the information is still there.
OK, yes.
However, with Hawking radiation, very slowly, a black hole actually reduces its mass. So over time, it gradually shrinks away until it's completely gone. There's no trace of the Earth, no evidence that it ever really existed, let alone what it was made up of.
And you can't retrieve that information in any way?
Exactly. It seems like you wouldn't be able to get at that information at all. So there's no way you could work backwards and work out that the Earth used to exist. It's just gone and lost.
So is there any way to resolve this?
We hope there's a way to resolve it, but right now it's fair to say nobody knows. And people are trying to resolve it in lots of different ways.
Despite 40 years of effort, the information paradox is still unresolved. If Hawking radiation exists, then we have to solve the information paradox. We have to work out what happens to the information as it falls into a black hole and how they can evaporate without destroying it. If, on the other hand, Hawking radiation doesn't exist, well, then something's fundamentally wrong with our understanding of black holes and perhaps even quantum theory. The problem is that theorists have raced ahead with these ideas about what black holes might be like, but how do we observe that they exist at all? The trouble is,